All right. We're chugging right along now here to the end of the conference with our session here on data processing at the tactical edge. I'm so sorry. I want to welcome everybody. You've probably seen me a few times already on sessions today, but want to still just go through a quick little introduction. I am Trey Pierce, and I head up solutions engineering here at Clarifai. I will be your moderator for this session. Before we get started, just a few housekeeping mentions. All attendees will be muted, but we do encourage you to ask questions, which you can do so by tapping into the typing into the Q&A widget in the top right-hand corner of the screen. We're going to hold maybe 10-15 minutes at the end where we try to answer all those questions at that point. Today's session will be recorded and we will make those available after the event. I couldn't be more excited to be introducing our accomplished session speaker, Captain Britt, who will be sharing some of his wisdom on the critical topic of edge processing. But before I do, I just wanted to give a little bit of background on Clarifai for those who might still be needing a bit of context on today's conference. Clarifai is the leading independent provider of deep learning technologies and services. Our end-to-end platform enables our customers to train and deploy computer vision and NLP models, helping to transform untapped, unstructured data into insights and actions. Founded in 2013 by former ImageNet Award recipient Matt Zeeler, PhD, we've since added more than 80 employees with offices in New York City, San Francisco, Washington, D.C., and Tallinn, Estonia. We received numerous awards by industry observers, including Forrester, who recently recognized Clarifai as a leader in the rapidly emerging market for computer vision platforms. Okay, with all that out of the way, I'm excited to have the honor of introducing our distinguished speaker for today's session, Jenks David TUBA, former retired Navy captain. Britt is the last name. Captain Britt leads Mantech's largest program integrating new intelligence, surveillance, and reconnaissance, ISR, sensors and electronic warfare systems into the U.S. Navy's Maritime Patrol and Reconnaissance aircraft. A U.S. Naval Academy graduate and Navy veteran, Mr. Britt served for 25 years leading national defense teams to mission success. During his military career, Mr. Britt served as a surface warfare officer, a P-3C Orion mission commander, and a leader at every level. Mr. Britt also served on the staff of the Undersecretary of Defense, Personnel and Readiness as the Deputy Director of Training, Transformation, and New Technology, where he was the defense policy advisor to President Barack Obama for the formulation and execution of Department of Defense distance education policies. Mr. Britt earned a master's in systems engineering analysis from the Naval Postgraduate School and a Bachelor of Science in chemistry from the Naval Academy and holds numerous certifications. Okay, with all that said, I'm going to go ahead now and hand things over to you, Captain Britt, who is going to go ahead and lead today's session.
Trey, thank you very much for that introduction. It really makes me sound very accomplished. Wow. I feel good about myself after that. I may have you introduce me every single day at work. I appreciate this opportunity to speak today at Perceive 2020. This is very exciting for us at Mantech and for me personally to be able to relay to you some of the innovations that we're actually doing at Mantech in a real fashion. And how they're actually starting to make an impact as we are starting to roll them out for some of our customers. Today, I'm talking to you about our secure tactical edge platform. And you see that 3 there in the title. It's because there's 3 key elements of this particular platform, and it's the 3rd version. This version here is our most advanced version. It's our most customizable version, and it's the one that actually is getting a lot of interest from a lot of our customers. I'll go ahead and start here with the presentation and talking about secure tactical edge platform and how we use it. Today, I'm going to talk to you all about the challenges of collecting data at the edge. We'll talk about what the mission and the challenge and how our solution meets that. I will also talk a little bit about how STEP does some autonomous solutioning, and it's very, very, basic because we're using information that we have put together ourselves. And I have a demo where we autonomously walk through some full motion video that we've collected. Finally, I'll touch on a concept of operations for how STEP would serve the tactical edge, whether that be on a ship, on an aircraft, supporting troops in the field, or wherever that tactical data edge may be for your organization. With this slide here, I'm laying out the challenge. The challenge as I saw it, operating both ships and aircraft for the United States Navy. We realized that once we were disconnected from the pier, or once as an airplane got airborne, our compute and data collection were limited. Our deployed, when I say deployed, disconnected from the pier, underway at sea, or airborne aircraft, the sensors that were provided allow us to collect data faster and at a far greater rate than what we can hold on board at many times, especially on aircraft as we're limited size, weight, and power. It's a little bit different on a ship, but still we're meeting those limits. So our deployed high capacity storage as it sits today is not robust to retain everything that we can collect. Also, our compute capacity is overwhelmed when we handle these massive amounts of data sets. Some of that is because we lack the bandwidth to reach back to those cloud resources that we have and cloud, virtual machines to process all of this data. It's a we go from a large culvert-sized pipe when we're connected to the pier or the aircraft is on the deck, to when we're airborne or underway, it's more like a soda straw, depending on which type of bandwidth path that we're talking about. And that's really our communication pipe. Our processing time increases because we don't have that compute. It is also overwhelmingly manual. So there's little, if any, automation in searching a lot of this data that we collect. And then also when we do sync back to the cloud with that smaller pipe, that sync is incomplete and we don't really have the resources to maintain data integrity as we're syncing back to our cloud, whether that be a mill cloud or that be back to a home core processing unit. Essentially, we don't have enough bandwidth, we don't have enough connectivity to always reach back to those resources. So it's important to use what is pushed to the edge at the best of our capability. As compute has gotten cheaper, as storage has gotten cheaper, and we've gotten better at some of those devices, it's important to push those devices to the edge. And that's what our Secure Tactical Edge platform demonstrates. So what's the value proposition of the STEP? The device that we have built, it provides the user with an environment that the user doesn't know whether you're connected to the cloud or not, because it is a hybrid cloud solution. When it's connected, it provides all of those services that the sailor or the soldier is used to operating when in a home location or when connected to a large pipe. However, when it's disconnected or intermittent connectivity or limited connectivity, it serves as an on-prem cloud solution, still providing that environment as all the important applications are containerized in that environment. It delivers this via an open microservices enterprise framework. And it also provides a multi-domain flexibility because we have included as part of one of the important tool sets in STEP, a one-way trust diode application. It's best in its class ability to provide cross-domain flexibility. Also, the way that we deliver it, it's very flexible. It's modular hardware. It's optimizable. It's customizable as to the customer's needs. We're agnostic. We are delivered as a service, if you will. STEP is not something that the customer needs to own. It's something that is leasable. And we deploy those using a continuous integration, continuous deployment model that is very possible for our customers. We also deploy it so it effectively utilizes the customer's bandwidth. So it provides light touch data analytics automation at the edge. It employs a tactical edge artificial intelligence technique or solution as customized by the customer. And it has federated flash storage on demand, which delivers that speedy data access, which is very important for artificial intelligence processes. We also deploy it with an automated secure application or a patching management that utilizes a low bandwidth delivery that we believe is capable of even being delivered through something as low bandwidth as a high frequency radio signal. So this device is 100% designed to operate in a DIL environment. As you can see down there, we've got some of our team members in this platform that we have partnered with to deliver some of the services that I'm describing to you today. This slide here is simply an overview of what the rack looks like. As I'm showing it here, it's 8 rack units in size, and those are typical rack units. We've got them somewhat hardened in a customized case, but the components here, we offer an integrated switch and a unified computing environment that provides performance AI that's GPU driven, which is important. I will touch on that a little bit later. We have a cross-domain solution, that one-way diode that I touched on earlier, and also a scalable data engine. Those rack units are typical data center rack units, so thinking if you were to look at this real size, you're looking at about 18 inches wide, each rack unit about 1.5 inches, 2 inches tall, and then about 33 inches deep. But it's recognized, it's meant to connect into your network. It gives your decision makers speed to getting information back to them, and we will talk about that as we move along here in the presentation. Some of the key benefits of the Secure Tactical Edge platform here, as I've talked about, some of the 3 key attributes, resiliency, elasticity, and availability, those are key tenets of any cloud-offered, cloud-delivered solution. Resiliency, the component is fault tolerant and is scalable on demand. Even though it's physically separated from the core, it offers synchronous replication and automated configuration management and patch management. That's stigging for military units. Utilizing very little bandwidth. These deployed in parallel also offer high availability. If one device is disconnected, one device is powered down, multiple devices take their spot with the resiliency and services when used together. It also happens inside the unit itself. Most of that is done through a container management service that we have deployed inside the environment. Many of you are familiar with Kubernetes or OpenShift. That CMS solution is we're agnostic to deploying that in the environment. It depends on the user. So that CMS-driven environment enables elasticity inside the environment itself. You can stand up, stand down virtual machines in an automated fashion. You can stand up different data stores and stand down different data stores in an automated fashion. For example, that keeps your sailors and soldiers or IT men or IT services folks from having to turn up and turn down services as required. Allows you to free up that person to go and actually do more important tasks, like, for example, safety of flight communications monitoring at the edge, for example. And finally, there is a tokenized isolation of services inside step that we deploy that really makes this a zero trust device when deployed to the tactical edge. And we believe that this is the first zero trust device that is able to be deployed to the tactical edge. As I touched on earlier, the platform is able to be configured. It's delivered in different scalable, elastic and resilient configuration. Basically to meet user requirements, as I point out there. If you are a user that really needs a lot of storage and want to use this as a storage device, the device can be configured that way. If you really just need a network and compute environment with little storage, it can be configured that way. If you do need a full cross-domain solution or multiple cross-domain solutions, it can be configured that way. The flexibility of this is also one of the, I think, key components or key performance key performance indicators that makes this different than other deployable services. If you look at, and I'll compare it against other, for example, many of you probably understand or are familiar with the Snowball or Snowball Edge. Those are very good devices. However, being able to customize them or configure them to your needs is very difficult, and doesn't mean that they're not good, devices for many different use cases. They're just very restrictive in how they can be configured. Once again, kind of point out some of the different components in there, and the standard device there shown is about 130 pounds. So it's really about a 2-man lift. If you're looking at putting it at the tactical edge, that can be broken into smaller components as well. Here, I want to talk about a little bit of the inside. We've talked about what our stack looks like from the outside, the power of the stack, but I want to talk about a little bit of the systems integration that we've done inside the stack. So what we've done with STEP at this point is we've built a neural network on board. I'll kind of take you around how our simple neural network that we've built on STEP, and I will show you a demo of it actually in action, or at least a resultant of it in action, in just a few moments. But let me take you through this slide a little bit. In the middle there, you've got kind of a data map flow where you got a sensor collection sending that information to our tactical edge device. The tactical edge device building and are collecting and then building a usable product to get into the Department of Defense information network there, that little graphic there in the map in the middle. But let me take you around to some of the key points here. Deep learning really is a subset of artificial intelligence, and I'll kind of refer to some of these concepts as we walk through here. But our neural network here, and there are many different types of neural networks. Ours is very, very basic. It's a collection of different steps, a collection of information. It's a collection, ours in particular is a collection of algorithms. We take those algorithms and put them through functions, and then we add weights to build a model. This model then performs a specific task for us inside STEP. In particular, these tasks could be recognizing specific types of vehicles, significant geographical features, or known targets. So once we have this fundamental model built inside STEP, we then need to train it over and over and over again, because we've got to educate the model or train the model to recognize the features of, like, for example, a naval combatant. These features that we as humans understand a Navy combatant. When I say Navy combatant, I mean a Navy ship. And it's not a container ship. It's not a cruise liner. It's a Navy combatant. They have a particular type of bow, for example. They have a particular type of superstructure. They have a particular type of a stern that we recognize as that's a warfighting ship, not a entertainment ship or a cargo ship. So we have to teach this model how to understand that. This is a highly computational process, as you all know, and STEP excels in doing this. It does this nature of work, excels in doing this nature of work, because instead of CPU processing, we've enabled it with GPU processing. That enables high amount of inferencing. So inferencing, once again, kind of tied back to analysis. That's where we run our trained model against all the new incoming data in order to gain insights. For example, we may want to know how many combatants are identified in this data set in order to gain maybe the total number of combatants per total number of ships, or maybe even where did that ship originate from, if we're able to collect that information and include it in our database. In most cases, the superstructure of a ship is discernible, from other ships. So that may be the key giveaway. And on that superstructure, we may want to know antennas. What type of antennas? And it may be placed differently on the ship as opposed to a non-combatant ship. Here, this is where the network can provide statistical information and provide predictions depending on how the imagery is presented or provided the system and how the system is trained to respond to it. So in our demo that I'll show you here in a couple slides, we walk through that in a moment. We're using full motion video as input for our analysis, and we take from that transfer learning. So transfer learning is a process of adding new capabilities or intelligence to an existing model. So as we were building our model onboard step, we realized that we needed to add some transfer learning. For example, if you're looking at that naval combatant, it's now in your search area of interest. We want to add the details of that naval combatant to that neural network so that it can then fuse that into the model, and you can now begin to get new inferencing with that new information. So I hope that I haven't confused you on deep learning fundamentals, and I hope that I've kind of walked you through how we've built it inside the Secure Tactical Edge platform, and I'll touch on that as we kind of walk through to the demo here. So how does it work kind of at a data level? I've talked about data challenges, and then here's how we map out our solution and perhaps our workflow, some of our toolkits, how we use our GPU and software. We actually use, in this case, on the step demo that you're going to see here, we use a VMware-enabled Horizon software stack to push information back so we can prepare it for the theoretical core, or pushing it into the cloud. So this shows an inference workflow. It's taking pixels, data, and offering it, pushing it to the right to gain insights. So you're getting speed of that decision to the decision maker. For example, the sensors on the edge, full motion video, acoustics, if we collect acoustic information, electronic warfare collections, or just mission software. All of that is ingested into our STEP server. And in this particular unit, pushing from the edge to the cloud, from the Tactical Operations Center or the Mobile Tactical Operations Center, whatever that may be for the Army, the Marine Corps, the Navy. When connected, pushing into the cloud, that offers alerts, analytics, visualization. So your external networking, your operations, your communications, logistics flows are all ingested and evaluated as part of that neural network. So that the emitter information converted into object of interest and are tagged or labeled for publishing to the cloud, for alerts to the cloud, as data analytics to the cloud. This is where STEP decreases time to insight, because in our neural network, we're already picking out labeled tactical information and only pushing what is important to the cloud rather than everything. So we're effectively utilizing that small bit of bandwidth that is that reaches out to that tactical edge. So that's important. That bandwidth is probably the most expensive part of this whole architecture to improve. That may be a satellite footprint. It may be a radio communications band. It may be plugging into a high bandwidth wall socket inside a building that building is located, not in the contiguous United States of America. It may be in a different area of operations, a different theater of operations, as we refer to them. So effectively using that bandwidth by resolving that information before you push it in the bandwidth is very important, and that's where we excel. So I'm going to walk through a demo here for you. The demo is a full motion video analysis. It's information that we've collected. And then we have, as I spoke earlier, we taught STEP to pick out different objects in the video and then point out to the user. The important piece of this is I'm calling this autonomous, and it is machine learning. I don't want to go all the way to artificial intelligence yet, because inside DoD in particular, artificial intelligence policies, artificial intelligence pathways, all are being figured out right now. STEP is built to take those artificial intelligence policies, algorithms, how the neural networks are supposed to work, and be very effective at the tactical edge for that user. So what we're showing here is an autonomously delivered set of data. Why this is important is I go back to the soldiers and the sailors that are out there collecting this data. They may not have time to manually walk through all this data. So the device is pointing out important pieces of the collected data in a very quick fashion. So our GPU, enabling our tactical edge platform with GPUs enables us also to effectively deploy a VM solution. In this example, we're using VMware's Horizon View, but it enables multiple remote machines back to the same device. This the GPUs also bring performance graphics processing, very effective for processing a lot of full motion video. And there's some screenshots of the full motion video. So this is just demonstrating how local analysts at the tactical edge are accessing STEP's capabilities in a federated fashion. This shows the STEP stack processing and ingesting information and delivering it to each of those analysts. So each of those workstations can be full thick clients, thin clients, but all the applications that those analysts need are readily available and are scalable to each of those analysts. They're readily available and in a containerized fashion, so they're very light touch with respect to updating the repository, updating the image of those containers is important, because at the tactical edge, you may not always have that full connectivity. So next slide, and I hope the demo plays here. I have not played it in a live fashion yet, but a note before we get started here. The demo is information that we were able to collect in an unclassified fashion. So the information that you're going to see is a lot of traffic cameras and some airport cameras. We were unable to get truly tactical data to demonstrate in an unclassified fashion, obviously, but you'll see cars and you'll see people. So what we wanted to do was teach our device, this is a car, this is a person. Tell us the difference. Make sure that you understand the difference. So we wanted to try to focus on how STEP can store information. So we collected a lot of full motion video and then process the full motion video in an automated fashion. Process multiple channels of this full motion video. So the full motion video database that we collected against were just open traffic cameras in Kansas City, Missouri, and some airport cameras. So you'll see this. So you're looking at a couple right now. It's frozen right now. A couple outputs of 3 Ubuntu machines. If you're unfamiliar with Ubuntu, it's an open source Linux-based operating system, which we have in this particular instance of STEP, and it's really a beginner's operating system for continuous integration and continuous delivery. So it's really good for OpenStack development on cloud-based systems. That's very key to our secure tactical edge platform. So there's other systems that can do the same. We just used Ubuntu here. So these Ubuntu instances are running on vMsphere. And each virtual desktop instance is backed by a virtual GPU, which we're going to splice that GPU into several different pieces. All of this is provisioned from our CMS solution on board STEP. We're using in this instance Kubernetes. We also have an environment that deploys OpenShift. So on the left, you got virtual machine A, and on the right, virtual machine B. Each is running containerized video analysis applications. So let me start here, and I'll kind of start talking through this. And so this is a recording, obviously. Virtual machine A, virtual machine B, both stood up. And each virtual desktop is utilizing a portion of the provided GPU in there. It's a T4 8Q GPU. That's an NVIDIA device. And as you can see, we're processing a lot of video here. So there we go. We're pointing out that the NVIDIAs are the GPU enabled, and we're splitting the processing capability of that one GPU between these two virtual machines. So I'm going to pause for just a moment because it does kind of run very quickly. As you can see, we have trained the virtual machines to start telling the user what is a vehicle, what's a person. You'll see vehicles are in a red rectangle, and people, you'll see people start to flow in here in a moment, are in a blue rectangle. We did have some problems. We kept thinking mailbox was a person. We haven't gotten to fixing that algorithm yet, but this is just a very basic neural network here. So each desktop agent is able to be stood down. So as we're erasing services, you'll see that each of the desktop agents is saying, wait a minute, you were supposed to have this much capability here for this user. And we're showing you the resiliency of the agent as it gets erased, it stands back up, and it's standing up this containerized independent video analysis application here. And we're churning through its many terabytes of video data in an automated fashion. So we're pointing out to the user, hey, person. So the large screen on the right there. On the left, car, person. We're actually processing 10 channels of video there and another 9 channels of video there. Here in the very end here, I just want to point out that yes, these are two unique virtual desktop endpoint clients. I didn't just grab these screens at different times, but that's different aspects of how we collect and can process that video data in a very quick fashion. It's important because we're annotating the information, presenting it back to the user as a key part of the overall amount of data collected. That's where the user then can parse that data and utilize the bandwidth effectively. So how would STEP be used in the field? How would the Secure Tactical Edge platform be deployed? This is our ConOps, our operational view, how we think the STEP could be deployed. Obviously, we want to link back to the core, but we're not focusing on the core. STEP is meant to be deployed out to where the tactical edge is, wherever your tactical edge is, wherever it's hard to get data back from. It may be a warehouse that's across the country. It may be a ship that's underway. It may be an aircraft or supporting an aircraft that's airborne. Maybe troops in the field. We're positioning the Secure Tactical Edge platform to be just that, something that can be used out in the field, can be plugged up as a flyaway kit or forward deployed intelligence node or an autonomous decision support aid that's deployed with a deploying unit, or perhaps even an artificial intelligence tool that speeds decisions back to the decision maker from the tactical edge. So this is my last slide here, Trey. These are some different vehicles of, hey, how can you get to STEP? These are some of the large vehicles that we work on at Mantech, and those are some of the ways that you can get to us. These are mainly Navy focused, but STEP is a solution that is that can support any of a user's needs because of the unique capabilities that are configurable inside it itself. So I hope we've got some questions here. I'm going to stop sharing screen and I'll go back
Yep.
to the video if that's okay.
Yep.
And,
and you can hear me again there.
I got you great, loud and clear. You heard me through the whole thing there.
Yes, indeed. I think you did such an amazing job that everyone's speechless. So
at the end of the day.
I did. I mean, so if you do have a few seconds here, I do have some own questions, you know, from my end. I think there's been, throughout this entire conference, been a lot of interest and conversation talking about Edge. Actually, we do have a question coming in from Chris Don here. He's interested, how are the racks cooled on your Edge hardware?
So that's a great question. Right now, each of the devices has its own cooling that is embedded inside the device. The device, the cases themselves are designed to offer increased side cooling, but I don't want to confuse anybody that's seeing this that these components are something you can stick in the back of a tracked vehicle and take out into the hinterlands yet. They do need some considerable amount of cooling space in order to operate at an optimum performance, that's for sure. Okay. So not as much as a data center, but we've got our test platform right now set up where we have the cooling that's provided, and we're constantly pushing airflow over that with the aid of a fan. We do have a temperature range that I can provide if needed of where it's most optimally will perform, and then also a humidity range. So there is some hardening certainly that could be done on the platform, but right now we haven't seen the need for it. I can tell you that.
Interesting. Yeah, we got another one coming in here. Oh, this is from Alfredo, from our head of platform here, actually. What are the limits of the GPU and storage on those devices? It's interesting. He left it kind of open. Any kind of limits as far as what you can actually put out on the air?
The limits with respect to compute, processing, and storage are really the limits of the customer's checkbook, quite honestly. Yeah. I hate to say that, but the more storage that you want, the more storage we can deliver. In that 8RU platform image that I had previously, I think we are limited in that 8RU to, I want to say about 720 gigabytes raw. I'm sorry, 700. Is that right? I know I'm sorry, 720 terabytes raw. Sorry.
We're going to
one figure off.
Important to get it right.
Yeah. We certainly can do that. I've got the information to back that up. Processing wise, we've got 8 in our developmental stack. We've got 8 of those NVIDIA GPUs that are parallel mounted, and we have not really done a benchmark, I guess, clock speed against it, if you will, for processing a standard set of data. But we haven't been able to throw anything at it yet that slows it down. I can tell you that. Those GPUs are pretty impressive as well.
It sounds like you're getting a kickback from NVIDIA right now.
Well, I will say I've been very impressed with the performance of those GPUs.
We have as well. We're also partners with NVIDIA, so I'm very impressed with what they're putting out.
You saw the NVIDIA sticker on one of the slides too. So
right. We got a question from maybe someone who might sound familiar, from Eric Olson. We have how do operators at the edge? Yeah. How do operators at the edge assist in model version control? That's a good question.
How do operators at the edge? So that's a great point. And, I think that an application or a service such as Clarifai would be something that when deployed on step would be an incredible force multiplier, because probably, anybody that does any kind of data analytics and works with, like, a Power BI, for example, it seems as if it's something that's deployable and then will be easy to get information out of. No, you nearly need a team of programmers to get the information out of it that you need. Mm-hmm. So giving the end user, the tactical user, that solution that is customizable and very intuitive to do that, I think is key. So that goes to one part training, but also, I think, a larger part intuitive tooling.
Very cool. I hope that answered it for Eric there. He also wants to know if you've looked into the A100 GPU Direct from NVIDIA.
No, I haven't. We're not using the latest and greatest yet. When we built the devices that we had, we built with what we were. Actually, we built, I think, with T4s, and that was the latest and greatest when we built this particular version. We're now building more versions, and it really depends on what the user's requirements are.
Mm-hmm. Yeah, it makes a lot of sense.
What the user's price point is too.
You're at a deep learning conference when you're making GPU jokes. I think all that sounds good. Only 3 minutes here left. I had my own question. Thanks everybody for chiming in with the questions, by the way. Really appreciate all of that. My own just question, I think, I could come up with a few, but what do you see as being the most pressing, especially lowest hanging fruit, coming immediately, biggest needs? I guess you primarily serve the public sector. Kind of use cases and needs coming out for actual edge deployments. They actually are going to need this and be deploying in the next 24 months.
That's a good question. I think immediately, DoD applications, but that's not always the case. There could be several federal applications, private applications as well. While I think that compute processing prices have come down low enough that now it is reasonable to put very high-end components out on the tactical edge, what there's going to be a large demand for, I think, over the next 24 months are orchestrated containerized services. So that framework of microservices that is facilitated at the tactical edge, so that a lot of this is automated, and then also have the ability to do a very light touch of continuous improvement, continuous deployment of the newest application, or touching that application for security patching, for example. I think there's going to be, if you look at what the Air Force is doing, if you look at what DoD is starting to position themselves at with doing containerized services or containerized applications, I think there's going to be insatiable demand for that type of services over any of the environments. They're pushing containerized applications to jets in real time right now. So the Air Forces are proving that.
Yeah, I think
it's only a matter of time for it.
Yeah, I think we're already starting to see that. Sorry to cut you off. Already in the public sector, and already even starting to trickle through to private sector as well. Well, that's all we got time for right now. I'm sorry, Yunshin, not gonna be able to field that last question there, but really appreciate Captain Britt, you being with us today and that great presentation on edge computing. For everyone else who joined, thank you so much for joining us for this session. Like I said before, a recording will be available and sent out within about 24 hours. Thank you all, and see you all soon. Have a good one.